Okay, we're looking at exercise 11B from the first year mechanics textbook, and we're on question 5. So I'm given an expression for the velocity, but obviously there's this unknown k, and then it sort of talks about acceleration. So first thing I'm going to do is just get an expression for acceleration. So what's this, question 5? Okay, so I'm told that v is kt minus 3t squared, and acceleration will be the differential of that. So kt is just going to differentiate to k. Think about what happens when you differentiate 5t, 3t, and k is just a constant. Okay, and then 3t squared will differentiate to 6t. Okay, so let's go back. So they want me to be able to find k, so they must give me some further information, because at the moment I've got two expressions that involve k. I've got one for acceleration and one for velocity, but there's not much else I can do. So there must be more information in the question, and there is here. So the initial acceleration of p is 4 meters a second squared. So the initial acceleration, that's going to be when t is 0. So when t is 0, the acceleration, I've already forgotten what they said it was, the acceleration is 4. Okay, so when t is 0, the acceleration is 4. So if I go back to my expression for acceleration, so acceleration is 4 when t is 0. So from that equation there, k must be 4. Okay, so on to part B. So using the value of k found in part A, find the acceleration when p is instantaneously at rest. So I'm going to find a value for an acceleration, but they haven't specifically told me the value of t yet. I've got to find that. So I need to think about this bit. So when p is instantaneously at rest, well, something is instantaneously at rest when its velocity is 0. So now I know what k is. I can say that that's the velocity. So it's going to be instantaneously at rest when that equals 0. So I take t out as a common factor. I get t is 0. Well, we already know the acceleration when t is 0, so that was given to us. And I'm going to get t is 4/3. So when t is 4/3, a, so I know that a is 4 minus 6t, so when t is 4/3, a will be 4 minus 6 times 4/3, so that is going to be 4 minus 8, so that is going to be minus 4 meters a second squared. And give that answer as minus 4 meters a second squared. It is the same as the deceleration of 4 meters a second squared, but let's not overcomplicate things.